Hi everyone, how are you all? Okay, I hope you are doing great. So today we are going to see few questions on handle and working of bottom-up parser. Okay, let's get started. So I hope you have seen the previous video, which is about the handle. If you have seen, then only you should watch this lecture. Otherwise, you should see the previous video first, right? Okay. So let's get started with the very first question. Let's just see what this question is saying. Given the grammar GE, indicate the handle for each of the right sentential form for the grammar this, right? So can you tell me the handle here in this right sentential form? Can you tell me the handle? So just let me know the handle in this form in option A. Let me know the handle in B. Let me know the handle in C, D, and E. So what are the handles, right? That's what we need to find out. Okay. So let's get started. Now, what is the handle in this option A? What do you think could be the handle? This is E plus E into E, right? So what do we need to do first? We need to generate the right sentential form. For now, like that's the procedure that we know, that if you want to generate this E plus E into E, then how you can generate? I think you can go like this, right? Maybe like this. And then you can say that this is this E can be reduced to, okay, this E can be reduced to, so you want to go to the right sentential form, right? So which means you want to reduce this E. So this E can be reduced to E into E, right? Okay. Is there any other way? Is there any other way to generate this? Let's just see. Can you see that if you go for this E into E first, then can you say that this E should be basically giving you E plus E or something? This E should be giving you E plus E. Can you say something like this in the right sentential form? In the right sentential form, can you say that that this E is reducing to E plus E? Let me know. No, right? So in the right sentential form, if you see in the right sentential form, there is only one way to generate this, right? Or let me know if you find there is any other way to generate this in the right sentential form. See, what you need to do, you need to generate this E plus E into E, right? Now, either you will go for this or you will go for this. There are only two options, right? So either you will go for this or you will go for this. Can you generate E plus E into E using this or using this? No, right? We cannot generate using this and this. So that is why we will either take this option or this option. If we take this option, then using right sentential form, yes, you can generate. But if you take this option, then we can't generate using right sentential form. So that is why this is the only option. So now can you tell me the handle? What is the handle here? What has just got reduced, right? What has just got reduced? So E plus E has just got reduced. So you will say E plus E is a handle, isn't it? So what is the handle? Let me just put a square bracket on this. E plus E, right? E plus E is the handle. Okay, understood? Okay, great. Now let me, so this was the option A, right? This is the option A where I'm saying that only one way using rightmost derivation. Okay, using rightmost derivation, there is only one way. Now tell me E plus E, what is the handle in this? What is the handle? Isn't it easy? So here for the option B, you will say it is just like E gives E plus E, isn't it? E gives E plus E. So what is the handle here? Just E plus E. What just got reduced? E plus E only, right? So this is the handle. Okay. Can you tell me ID plus ID into ID? So this is the option C where we need to tell for ID plus ID into ID. Okay. Let's just see using the rightmost derivation. Let's see if you have this one, then this can go to E plus E into E, ID plus ID into ID. Now this will go to ID, this will go to ID, and this will go to ID. So basically, you can say using the rightmost derivation, I'm finding out, right? This will go to ID first, and then this will go to ID next, and then this will go to ID next, right? Okay, this is one way. Can you see if there is any other way? Can you see if there is any other way to generate ID plus ID into ID? Let's just check. Okay, using RMD only. So this E can go to, I want to generate ID plus ID into ID. This E can go to, let's suppose, okay, earlier we have taken the option E plus E, right? Now let's suppose I take the option E into E. Now using this, can you generate this? Let's just check. This E can go to, ID, right? This E can go to ID, and then this E can go to, E plus E, right? And then this E can go to ID, and then this E can go to ID. So yes, I think we have generated, right? So now in this, like this is a valid right central form, and this is also the valid right central form. So both are the valid right central form, right? So what do you understand from this example? That if there are multiple, so see, if there are multiple right central form, so this is one way, okay? And the second way for option C, right? For option C, the second way we have seen is basically if you take this first, E gives E plus E if you take first, then this E into E, and then you will say it is E plus E into ID, and then it is E plus ID into ID, and then this is ID plus ID into ID. So yeah, this is a ambiguous grammar, isn't it? Because there are multiple derivations possible for a same string. So that's why this is an ambiguous grammar. But anyway, can you tell me the handle? I think in this grammar also there is a unique handle. So what is the handle? What is the handle here? ID, right? ID. So yeah, the first ID. Basically, we have subscripted, like they have subscripted ID1, ID2, ID3. So if they're asking for the handle, you also need to tell the position. So you can say the handle is ID at position 1. Okay, this is the very right definition. If you just say ID, if you say a handle is ID, it is not a very clear that which ID you are talking about. You should also mention the position. So handle also consists of position. That's what we know, right? Understood? Okay. Okay. Hope you got it. Now let's just see the next question. So basically here in this question, the ID was the handle, like in the option C, right? So let's see E plus E into ID. Let's see the third option, E plus E into ID. Okay. Yeah, this grammar is ambiguous. That's fine. Let's not worry about whether the grammar is ambiguous or unambiguous. Let's just find the handle if we can find the handle. So let's just see for option D. For option D. Let's just see what is happening. So D option is basically saying E plus E into ID, right? E plus E into ID. Okay. So what should be the handle here? So this E can go to, again, I think it is E plus E into ID, right? So I think this is this much, right? E plus E into ID. So this E plus E into ID, we can generate in again two ways. So let me just copy both of the ways on the next page. Okay. So here, like we have already generated this E plus E into ID. So that's why I'm just directly copying it, right? Instead of regenerating and writing everything again. So this is E plus E into ID, E plus E into ID. Now, can you tell me the handle? Is this the right central form? So both are the right central form. So what is the handle here? Here we have multiple handles, right? That's fine. I mean, if this is ambiguous grammar, we can have multiple handles. So what is the handle here? Here handle is E plus E, or so in this E plus E, in this E plus E into ID, you are saying handle is either E plus E, or so basically there are multiple handles, or maybe you can say the handle is what had just reduced ID, right? The handle is ID, or maybe the handle is E plus E, right? Is this fine to everyone? Okay, so whatever had just reduced, so basically here this E had just reduced to E plus E, here this E had just reduced to ID, right? So that's why you can say maybe the ID is a handle, or maybe this E plus E is a handle, right? It depends on you, like how you're treating it, right? Like both are fine. So what is the answer here? So here the answer is, you will say, okay, by the way, tell me, for unambiguous grammar, can this happen? Can you have multiple handles for the unambiguous grammar? Let me know. So answer is, can you have multiple handles for the unambiguous grammar? Okay, both are handles. So we have multiple handles here, right? So we have just noticed that we have multiple handles here. Now we have multiple handles for given right sentential form. My question is that, can we have multiple handles in unambiguous grammar? You should be able to answer this. Handles in unambiguous grammar. Yeah. So the answer is no, right? The answer is no. Why? Because only one. So you will say only one rightmost derivation. Hence only one handle, right? Hence only one handle. Okay. In any right sentential form. In any right sentential form. Okay. So in option D, we have multiple handles. That's fine. Okay. So here E is a handle, E plus E is a handle, or ID is a handle. Now tell me E plus ID into ID, E plus ID into ID. So which means E plus ID into ID, this much, right? Now let's just go to the option E. So maybe I can just copy these things and let me just show you. See, they are saying E plus ID into ID. In this, can you tell me the handles? This is option E. So what are the handles in E plus ID into ID? I think here this E just reduced to ID. So that's why ID is a handle. Here, this E also just got reduced to ID, right? So that's why ID is a handle. So anyway, I think there is only one handle, right? Only one handle, which is the second ID. Oh, sorry, the first ID, right? Yeah. So ID at position, what is the position number? If this is position number 1, this is position number 2, this is position number 3. At position 3 is handle. Okay, is handle. So this is answer. So in both cases, this is coming out to be handle. This is just one handle, that's fine. But there could be multiple handles also. Okay. In ambiguous grammar, there could be multiple handles also. That's my point. Like, I mean, basically, sometimes we have one handle for some string. Sometimes we might be having multiple handles also. Okay. If the grammar is ambiguous. Is this fine? Okay. So let me know if you have understood all of these options. Easy only. You just need to drive it and just need to see that what is happening. Okay. Let's just go to the next question. What they are saying. This question I have taken from Columbia University. So let's just see what they are saying. So what they're saying is that, let's just read it out, that they have given you some grammar, which is this. Now they're saying construct a rightmost derivation for this. Okay. And show the handle of each right sentential form. So they want the handle in each right sentential form. Okay. Not just one or two. I mean, not just only one right sentential form. They want the handle in each right sentential form. Okay. So let's just solve this. Now, basically, we want to generate this, right? This open parenthesis. Okay. Now, can you tell me what will happen? I think I should first go to this, and then then this L should generate this, all of this, right? So maybe I should go to L comma S. Okay, so this and then L comma S. And then I think this L should generate this much. Okay, and then okay, so by the way, this is the right central form. So let's just keep on doing it the right way. So basically, this is L comma S. Now I think this S. So what it should do? Can you tell me? I think this S should generate this A, right? Okay. So in the right sentence form, what should happen to generate this particular string? Can you write the right sentence form? So it seems like that this S, because you don't I mean after the comma you don't want the bracket, right? So that's why this S should go to, you have two options here, either this or A. So which one you prefer? After the comma, do you need the brackets? No, right? You don't need the brackets. So basically you need A. So that's why it seems like it should go to like this. And now I think this part is done. At least, I mean, it seems like, and with the comments, this is done. Now this is also done. So using this L, I think we only need to do this much, right? So now you tell me this L should be going to S or what? Or L comma S. So we want to generate, finally we want to generate using this L, we want to generate this, right? So if it goes to S, then S gives, okay, so this L, if it goes to, if it goes to L comma S, okay, then also it is fine, right? So let's just see. So maybe let me just see if it goes to L comma S. Okay, so L comma S comma A, if it goes to L comma S. Now uh now since it is a right central form, so that's why from this S we again want A only, right? So you can say L comma A, right? Now since it is a right central form, that's why I will explore this L. Now this L should be generating, I think, bracket and A, right? So I think this should go to S first. Okay, and then this should go to L, and then this L should go to S, and then the S should go to A, right? So that's the sequence that we need to follow. And then this S should go to A. Okay. Now let's see what happens if you take after this L, instead of taking L comma S, if you take the other option. Can you generate the right schedule form after this L? Instead of L comma S, let's just take the other option. What is the other option here? So see, we have taken the L comma S, right? So from this L, one option was we wanted to generate this. One option was L comma S. Another option is S only, right? So let's just see that what is happening. If you take S here, now this from this L, basically we want this particular thing, right? Now we are saying that from this S we want this. So if you want this, then we want the comma, right? This is basically L comma S. So I think you can generate, right? So this S can go to, okay, see, from comma. Now can this S generate this? That's what I'm saying. Um See, if you go for this, the problem here is that if you go for this, then everything will be in the bracket, right? Everything will be in the bracket, whatever you generate next. We don't want everything in the bracket. So if you go for this anyway, this is the end. If you go for this, then everything will be in the bracket. We want some part in the bracket, some part after the comma. So if we go for, let's suppose if we go for capital L from here, then can you generate can you generate from this? Can you generate this? It is impossible, right? Why? Because here there is, I mean, there are some things which are not in the bracket, so I think we can't generate. So basically this option is not giving you right sentence form, right? This option does not lead to, so this basically there is only one right sentence form, right? One rightmost derivation does not lead to string, which is this one, right? This option does not lead to this string. So only one RMD exists. Okay. So only one RMD for only one RMD for this string. So basically, for the given string, there is only one RMD, which is good, right? I mean, we are actually good with that. Okay. Now they are saying that tell the handle in each right central form. So what is the handle here? Can you just underline the handle? Maybe you can do this, right? This is the handle. Can you just underline the handle here? This L has been just reduced. So I think this is the handle. Can you underline the handle here? So I think this A is a handle here, right? This A is a handle here. Can you again underline the handle? So I think this L comma S is a handle. Now this A is a handle. Okay. And then this S is a handle because L gives S. And then I think everything is fine. And then this is a handle. And then this S is a handle. Then this A is a handle. Okay. So that's how you can tell handle in each of the right central form, because they want in each of the right central form. Okay. They want in each of the right central form. So I hope that is fine to everyone. Okay. Easy question, but just for the sake of practice, we had this question, and the question is from Columbia University. Okay. That question is from Columbia University. Understood this question? Great. Now let's just move further, right? I hope you understood this question. Okay. Now let's just see what they are saying. This question I have taken from some link, some assignment of or the homework from some university. Let's just see. So they are saying using this grammar whose terminals are A, B, and C, construct a rightmost derivation for this and show the handle in each right central form. So can you do this as an homework? I don't have the answers, but you can do as an homework, and then you can give the answer, okay, in the comment section. So just do this as a homework. Is this okay to everyone? The question is same. They are saying the show the handle in each right central form. Okay. So you just need to show the handle in each right central form. Cool. Now let's see this question. They're saying consider the following grammar. This is given to you. Which of the following is or are handles in? So this is MSQ question. Okay. So they are saying which of the following is or are handles in the generation of the right central form XXX YXY. So let's just see this question. So they are saying XXX YXY. Okay. So if you want to generate this, then this is saying all the X and ending with Y. So it is basically all the X and ending with Y. So this is one Z, I think. This is another Z, right? These are the two Zs. Like, I mean, from this grammar, at least you can see that this Z is nothing but all the X and ending with Y. So this is all the X and ending with Y, all the X and ending with Y. So if you have done TOC, then I think this will be very, very easy to recognize that, okay, this is Z, right? Is this okay to everyone, that this is straightforward to recognize that this is Z and this is Z, right? Okay. Now let's just see this. Now this S will give you Z from this first or from the second Z, because this is a right central form. Okay. From the second Z, we want to generate XY. So what we will do? This Z will remain as it is. This Z will say that I should go to XZ, right? And then this is X Y, right? XY. And then this Z will be generating 3X, right? So first you generate 1X, then you generate second X, then you generate third X, then you generate the fourth X. Okay, then you generate the fourth X. Sorry, there are only three Zs. This Z will generate now Y, right? 3X. Now this Z will generate Y. Okay. Now what are the handles here? I think this is the handle. Since this Z got reduced to XZ, this is the handle. This Y is a handle. And then this XZ is a handle. And then this Z is getting reduced to again XZ. Then this XZ is a handle. Then this XZ is a handle. Then this Y is a handle. So what are the handles here? Is ZXZ is a handle? This is a handle in this process? No, right? ZXY is also not handle. Even though this is MSQ, but it seems like only one of the options is true. XZXY. XZ, no, this is also not the handle. only xz. Yes, this was the handle, right? This was the handle in one of the right sentence form. This was the handle. Okay, even though this question was MSQ, okay, but still only one option is correct. Let's suppose the option E I say, for example, option E I say, is there any right sentence form in this process that by is a handle? What do you think? Is by a handle in any of the right sentence form? Then answer is yes, right? So this is option E, let's suppose, right? Is by handle? Yes. Let's suppose option F is, this y was a handle. This xz, I think they have given. Okay. So maybe let's suppose zz. So what are the handles? The number of handles here. I mean, if you just look at the I mean here, see this S gives zz. If you just look at this particular right thing, then how many unique right things are there? I think it's zz, xz, y, right? Three, zz, xz, and y. Okay, I think three unique things that can also be asked as an NAT, right? That how many unique handles are there? Okay, irrespective of the position. Okay, let's not worry about the position. Irrespective of the position, how many unique handles are there? So what are the answers? Three. So here, this E and F both are the answers if there are options, right? Okay, understood. That's really easy question, but as you can see, this question has got 15 upvotes, right? This question has got 15 upvotes, and that was not a gate PYQ, by the way. That was just a normal question, and I mean some aspirant has asked. So it means that people are struggling. So this tells you that people are struggling to find the explanation of the handle. But I hope you understood this very well, right? So what is the handle? But don't worry, I mean, you will get to understand the need of the handle also. It's not just that you understood the handle, you will also get to understand the need of the handle. Okay, let's just see. Okay, so let's see this. Using the following grammar, draw the parse tree and show the parse tree simple phrases. Okay, let's just worry only about the handle. Okay, let's not worry about this simple phrase and all. Show the handle for the following right sentence form. Okay, so so okay, have you generated the wrong string in the previous? X x x y x y, that's what we want, right? X x is y. Oh, sorry. So this is x y z. No, that was correct. I forgot to write just x here, right? The string was correct. Okay, I forgot to write the x here, otherwise it is correct. Okay, I mean, while I was copying this from here to here, I just forgot it. Otherwise the things are correct here. Okay, now let's just see this. Now they are saying that you need to tell show the handle for the following right sentence form. So given this right sentence form, you need to tell the handle. Can you tell the handle in this right sentence form? What is the handle here? Okay, this is basically A, capital A, 3 times C, and then 2 times B, and then C. So if you want to generate this, then let's just see how you can generate, right? So obviously you will go for this, right? You will go for this. So which means here the very first option is this. And from this b, if you have the options, that will you directly end with this C, or you will go for this B, or you will go for this? Which one you will take? What do you think? See, this is obviously not the option. You don't want to end with B, and then maybe you can do this, or maybe you can do AC. But here, this A is basically saying that you have all the B's, or you have A followed by double B. Okay, let's just try with AC. Okay, maybe I might fail. I don't know actually, but let's just try with AC. Okay, so this C and this C is matching. Now for this A, what we should need to do for this A? I think we can try with AB. Okay, we can try with AB, right? Now for this next A, what we should need to do, this is matching, that is good. For this next A, okay, we want a small a and then capital A. So I think from this capital A, we will go for this, that's fine. But for this capital A, what we should do? Okay, let's just try with AB. So basically, AB, for this BC is already there. Now I'm writing for this capital A, I'm writing AB. Okay, for this capital A. Now I think this BBC is matching. So that's why what we should do now, we should generate this much, right? Now, can you tell me for this capital A, what we should be doing? Again, for this capital A, what we should do? This BBC is matching. I think we need now C. So obviously, like you don't need B. So you will not go for this. So you will go for ABB, right? So for this capital A, you will go for ABB. So this is A, B, A, B, 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 C, right? This is ABB, which is new one. Okay. So I hope you are getting it. See, this is for this capital A, we are going for ABB. So which means A, B, this BBC is fine. Now for this capital A only, we are going for ABB. Okay. Sorry. ABB. Now what we should do? This is matching. This is matching. Now I think this BB can go to CC. That's fine. No, we want 3 C's, right? Okay, this is BBC. If we have A, isn't it a problem if we have A? Yeah, we have also got 3 B's, right. That's also the problem. Yeah, so we have only 2 B's, right? So since we have only 2 B's here, I think that should, these 2 B's are fine, right? After that, okay, maybe there is some mistake here. So this C is matching. This is B. From this A, okay, this is BBC, right? Yeah, it seems like that there is some wrong thing that we did. So instead of doing this, because it is not generating the right sentence form that we need, now we can say that, okay, from this, this B, if this B goes to AC, right? Then that was not a good case. So maybe let's just see if we are saying that this B is directly generating C. Okay, this B is directly generating C. Now we have BC. Now from this A, we want to generate this whole thing, right? So this is, can this be ABB? So from this A, we want to generate this whole thing. So let's just see. So from this A, can this be A? And then this is BB, right? So this is B. And then can this be the next B? Yes, right? Yes. So basically this is, I mean, we can generate. So you can say this is basically A, this is B, this is the next B. And this ABB, this is what we want from this capital A, right? So from here, you can say that this is small a, and then capital B, BC, and then you want to explore this B. From this B, you will go for CCB. You ultimately want CCB. So that's why you will say this is A, B. From this B, you want C, capital B, small b, C. And then from this B, you will go for C, right? CCB. So you will say that this is A, B, C, C, B, C. And then from this B, you will go to AC. So finally we have generated this ACC CBC, right? Okay. Now they are saying that a right transfer form in the system. What is the right transfer form? So what I just reduced. So I think the CBC till C is fine. So B has been reduced to AC. So what is the right transfer form in this particular string? AC, right? AC is the right. Oh, sorry. AC is the handle here. AC is the handle in this particular right transfer form. What is the handle? AC is the handle. Okay. Okay. Hope you understood. So that's how you can do this B and C also. So here, just a second. Let me just go to the next page and then write the answer. Okay. In the fourth production, 1, 2, 3, 4. Here two B each will come. You are saying that. So this is AB. This BC is fine. AB is fine. So this B is going to CB. Yeah, that will be one more B. Yeah, I agree. Yeah, I mean, okay. Again, I forgot to write it, but yeah, that's fine. Okay. So everything is fine. So the answer here is AC. Okay. AC is handle. Hope you understood, right? Okay, sorry. I don't want to do that on this page, but okay, I will copy it, remove it, because later on you can solve these questions by looking the annotated notes. Okay, if you don't want the solution directly, then you can do that. Okay, anyway, so let's move further. Let's move to this particular question. So anyway, like there are I mean multiple questions here. You can do remaining as an homework, right? I mean, you just need to generate the right sentence form and then you can do it. Okay. Now let's just see. They're saying this is a right sentence form of the grammar. So the handle. So again, can you do this as an homework? They're the similar type of questions. Okay. So what is the handle? You can do it as an homework, right? So now again here also they are saying that you need to underline the handle in each right sentence form. So again, like that is doable. Okay. So again, you can do this as an homework. Now let's see this question. What they are saying. Below left are the simple below left are simple bottom up parser and parse tree of the right sentence form derivation. Identify the handle. So basically they have given you some parse tree and now they are saying using this parse tree, can you tell me the handle? Okay. They're saying place a circle around the handle. So what is the handle here? Just looking at this parse tree. I mean, you can do the right sentence from derivation and all, but can you tell me just looking at this parse tree, what is the handle for this right sentence form? See, if you go for the right sentence form derivation, so you will say this is E, and then from this E, you want to generate T into E plus T. So you will go to T, and this T will say, so this E is going to T, this T is going to T into F, and then this F is going to T into T into this F is going to bracket E, right? Bracket E, and then this E is going to E plus T. So what is the handle? This E plus T, right? E gives E plus T. So if you want to place a circle, then this is the circle, right? That is the answer. So E gives E plus T. I mean, this E plus T is a handle. Some people directly say that E gives E plus T. I mean, you can say this is also the handle. Basically, the position also matter. So you can say that E plus T starting at the position 1, 2, 3, right? At the position 3, E plus including, sorry, at the position 4, because this bracket is not included. So that's why at the position 4, this is the handle, right? This is the handle. Okay. So let's see this question, which I have taken from Illinois University. What they're saying, here is a standard expression grammar that you have following the parse tree. Okay, this is a parse tree. Circle and number the handles in the order which are pruned in the shift reduce parser. So basically they are saying, if you have this as an like this is your, let's suppose, the right sentence form that you have, then can you tell me what is the very first handle that you had? See, the parse tree is given to you. You don't need to do anything. Let me draw the, using this parse tree only, let me draw the right sentence forms. Okay, let me quickly draw the RMD. So tell me what will happen. This T will be T into P. You are just mimicking this. Okay, you are just mimicking this. Then this E plus T into Z. Then this will be, this capital T will be P and then Y, right? E plus P into Z, and then E plus Y into Z. Then this E will go to capital T, and then this capital T will go to P and then X, right? Okay. So it will go to, I'm just mimicking what is given to me. Okay. I'm just mimicking it. I'm not doing anything else. So this capital T will go to P, P plus Y into Z, then X plus Y into Z. Okay. Now they are saying that what are the handles in the order you need to tell me. So in this string, what is the handle? X, right? X is the handle. So that's why they are saying, let's just circle it out. Okay. This is the handle number 1. And ultimately the handle number 8 is this. Can you tell me the handle here? What is the handle? This P is a handle. So can you tell me the handle number 2? This T gives P, right? So can I circle it out? Can I say this is the handle number 2? Tell me. Now can you tell me the next handle? Next handle that you have, it is E gives T, right? So this is the handle number 3. Now can you tell me the next handle here? So I think this is by gives, this by is reducing to P. So I think this is handle number 4, right? This is the handle number 4. Now can you tell me next? I think this should be the next. This is 5. Then this should get reduced to P. This should be 6, right? And then ultimately this is 7. And then this is 8. Is this fine to everyone? That how we are telling the handle numbers also? So they are saying, the question is this, they are saying that circle the circle and number the handle in the order in which they are pruned. Okay, pruned means they get used basically. Okay, in shift reduce parser is nothing but bottom up parser. Okay, shift reduce parser and bottom up parser is same. We will see that. Okay, we will see that. Is this okay to everyone? That what I'm trying to say here? Okay, great. So this is the answer, right? So you can tell the handle number. Okay, this was the first handle, this was the second, this was the third. Now can you little bit feel this, that see what is given to the bottom of parser? X plus Y into Z, isn't it? It was given to the bottom of parser, or E was given. Bottom of parser will start from this or from E? Tell me. It will start from E? No, right? It will start from X plus Y into Z, isn't it? Now can you little bit try to feel this? I mean, you will get the complete feeling later on, but for now can you just try to feel this little bit, which means it will start from X. It will say, okay, let me reduce this. Then further it will say, oh, I mean, it will not even look at this plus, right? Even before looking at this plus, it is saying, okay, let me further reduce it, and let me look at the plus next. So it is doing what? It is saying that, okay, oh, I got X, oh great, let me reduce this to P. Then we say, oh, this P also should be reduced. See, it can be reduced is one thing. It should be reduced is another thing. So parser should be intelligent enough to make the decision that it should be reduced. Okay. So don't worry, you will get to understand. So what I'm saying here is that the parser will say, oh, let me reduce it. Oh, it should be reduced. Okay, let me reduce to T. Oh, it should further be reduced. Let me reduce to E. Okay, even before the consuming this, it is basically keep on reducing, isn't it? Then it will consume this. Then, oh, this plus. Okay, so currently what I have with me as a bottom up parser, what I have with me in the right sentence form, can you tell me? As a right sentence form, I have E plus Y into Z. Okay, so this, I don't have this X anymore, or do I have? Tell me, do I have this X anymore? As a bottom up parser, if I reduce this to P, then I have P instead of X. If I reduce to T, then I have T instead of X, or instead of P, then I have E instead of all of this. Okay, so currently I have this. Now I got this. Okay, now I was at E. Okay, let me check. Can I reduce this, or should I reduce this E to something? I think no. Okay, now let me look at the next symbol, right? Let me probably look at the next symbol. Now I will look at the next symbol. Should I reduce this plus to something? I don't think, right? This plus is even reducible. Or should I reduce this maybe E plus completely? Should I reduce this? I don't think these are the good thing. So maybe let me move to by. Then it will say, oh, now let me reduce this to p, right? Now it will say, oh, let me further reduce it to a to t. Now should I reduce this further to e? Tell me. Should I reduce this further to e? So I have reduced to p, then I have reduced to t. Then then see, it's not like that. If you have the production e gives t, then you should always reduce. No, it's not like this. Parser should be intelligent enough to tell whether you should reduce or not. So let's suppose my parser is intelligent enough to say that, okay, let's not reduce it further, otherwise it will be the problem later on. Okay, we will see that how to build that intelligent parser. We will see that. But for now, understand that what parser might be doing. Okay, so from this, I'm just trying to explain you that just try to see that what parser might be doing. It might be saying that this x, oh, let me reduce to e. Then it might say that, okay, plus, let's not do anything. Let's, oh, by, let me reduce to p, then to t. Then it will say that, okay, let me stop here. Then into, let me not do anything. Then, oh, let me reduce to p. Should it again reduce to t? Tell me. Should it again reduce to t? Should it go to t? Tell me. What do you think from this parse tree? No, right? So basically my parser, see, the parser is very intelligent, right? So here the parser is telling me that you should go till E. Here the parser is telling me, no, you should go till T only. Here the parser is telling me, oh, you only remain at P, right? So parser is very intelligent. Okay. Now tell me, as a bottom-up parser, what do I have? Currently, with me, as a bottom-up parser, what do I have? I have E plus T into P, isn't it? I have E plus T into P. As a bottom-up parser, I have E plus T into P, isn't it? Okay. Now I have this much in my hand. Okay. Then I will see that, okay, what should I do? Then probably let me do one thing. This T into P. Okay. This T into P, let me reduce to, so we are further reducing this to T. And then E plus T. Okay. This E plus T, we are reducing to E. Okay, this might be the bottom of parser doing. We will see very good details later on. But what I'm saying that, okay, it might be going left to right. Oh, should I reduce? Should I reduce? Okay, further. Now, before consuming the next symbol, it will do all the reductions. It's not like that. Okay, it's not like that. See, it's not like that. That it will see. Let me just explain you that. See here, it's not like that it will say that, okay, this is why, this is I mean, let's suppose it will say that, okay, let me अभी तक के लिए तो एक काम करते हैं, p तक ही reduce करते हैं. Okay, so it will not say something like this कि अभी तक के लिए तो p तक reduce करते हैं. And then what we will do, let's just see this, what is next. Okay, plus is here. Okay, now I have p plus with me. Now this is y. Okay, this y, now again p. Okay, फिर याद आया, अरे यार इस p को तो t में कर देते. It's not like that. What I'm trying to say here is that whatever reductions are there, you will keep on doing it before consuming the next symbol. It's not like that. It's not like that. You have some string. Let's suppose you have this with you. Okay. Currently, let's suppose you have reduced this to P. Okay. As a bottom-up parser, I have P plus Y into Z with me. Okay. As a bottom-up parser. Now, the bottom-up parser will not say that, okay, let me consume this plus also, and P को तो बाद में देख लेंगे. It's not like that. If the reduction is there, it will see the number, right? See the number. This is the next number that you are doing. This is 1, this is 2, this is 3, right? See here, these are the numbers. So it will still start from this. It will say that, oh, this X is a handle, let me reduce. Now what is the handle? What is the handle in this? This P is a handle, let me reduce. Okay. Now T is a handle, let me reduce. So these are the numbers. So basically, it will not be like that, okay, this is the current rational form. Okay. Now it's not like that. Okay, P plus को देख लेते हैं. मतलब let me, my input pointer is here. Let's suppose this is the pointer. Okay. Now I have only seen this. Now, okay, let me just see this also. Then if I have to reduce this P, I might do it later. Will it do like this? No, right? It will reduce this P to the maximum extent it wants to before consuming the next symbol. Is this okay? And we will understand that in very, very good detail. Don't worry. So that's called handles are on top of a stack. Okay. Handles are always on top of the stack. We will see that what is the stack and so on. But what I'm saying here is that you will not be consuming all the symbols and then later you will realize, oh, एक काम करते हैं, this x को reduce कर देते. ऐसा नहीं. It's like कि whatever reduction is there, you will keep on reducing it before consuming the next symbol. Okay. Anyway, you will get to understand. So currently I just wanted to give you the feel here that how bottom-up parser might be doing. Okay, it might be first looking at x, and then maybe it will say, okay, this x is a handle, let me reduce it. See, that's what we are saying, right? Given this, if someone tell you what is the handle, want to immediately reduce it, right? So if someone tell you here also what is the handle, want to immediately reduce this p to t. So that's what the bottom-up parser also do. Okay, but who is telling you the handle to the bottom-up parser? The algorithm, like on which they are relying on. Okay, so anyway, you understood this question at least, that what are the numbers and how bottom-up parser might be doing, right? It might be reading from left to right, it might be reducing like this. Okay, it might be reducing these things like this. Okay, now let's see this question, what they're saying. Given this, can you tell me, if I treat this as a left central form, okay, then of whose handle is, then A gives B at position 2. Okay, so let's just go to the next page. Can you tell me, if you treat this as a left central form, then what is the handle? If you treat this as a right central form, then what is the handle? See, I think this is the same grammar that we have. This is A, this is E, this should be D, right? This should be B, and then this should be capital A. Okay, this whole thing should be capital A. And then ultimately this is S. Okay, anyway, so let's do the LMD, leftmost derivation. Okay, so if you do the leftmost derivation, this capital A should go to which thing? Should it go to B, or it should go to ABC? ABC, right? And then this should go to B, and then this B should go to D, right? This is the leftmost derivation of this string. Can you do the rightmost derivation of this string? So this is, till now it is same, obviously. Now this B will go to D. This A will go to now ABC. This capital A will go to B again, right? So this is the rightmost derivation of this string. Now tell me, what is the handle if I treat this as a right central form? What is the handle? I think this B, right? This B. If I treat this as a left central form, then what is the handle? This D. So this is the position number 1, 2, 3, 4, 5. So at position 5, you have this as a handle if in LMD. At position 2, you have this as a handle in RMD, right? Okay. So basically, here, can you tell me what is the answer? So what is the answer? This is a MSQ question, by the way. So in left central form, I think BD is at position 5, right? I think this is true. In right central form, I think AB at position 2. Okay, B and D at 2, right? Understood? Okay, okay. So generally we don't need the left central form because all of this is basically for the bottom of parser, which uses the right central form, and we will see that how it is using. Okay, we will see that. Don't worry. So just do this question also as an homework. Now let's just see that what is the idea in the bottom of parsing, that how we are parsing, right? What is the idea? Now, as you see that what we will be doing in the bottom of parsing, it will be given, right? It is given in bottom of parsing. I mean, we will start from here, right? So what is the idea? We will start from here. If someone tell you that handle is something, okay, let's suppose we will start from here. This is same. If someone tell you some handle, then can't you go here? If someone tell you handle, can't you go here? If someone tell you handle, can't you go here? Someone tell you handle, can't you go here? And ultimately we will reach to the S. So that's what we are saying, that we will start from this last sentence form. I mean the input string, basically. Find the handle. Okay, whatever is the handle in this, replace this handle and go to the previous thing. Isn't it? So this is the whole idea in the bottom of parsing. But how we are finding the handle and how to do all of this, we will see this. But is this little bit clear that what I'm trying to say? We will start from this input string. We will keep on going to the start symbol. How? By finding the handle. Okay. This is the crucial step, that how to find the handle. Okay. So now let's just see working of bottom-up parsers, that how the bottom-up parser is actually working. Okay. Cool. So let's see this very first example here. This is basically having, I think, only one string. Let's suppose this is the string that we have, and I want to use this string to reach the start symbol. Okay, basically I want to parse this string. Now tell me as a human, okay, don't worry about the algorithm. As a human, if someone tell you that you start from this ABA, what you will do? You will say that, okay, I should reduce. So currently you are at A. Should you reduce this small a to capital A? Tell me. You should reduce, right? You will be reducing it. So that's the very first thing that you are doing. So you're reducing this to capital A. Now tell me what you will do. Now you will read this, right? You will read this. Want to reduce this also to capital B? Tell me. You will reduce this. Now you will read this small a. Should you reduce this to capital A? As a human, I'm just asking you, okay? Don't worry about the algorithm. How the algorithm will figure it out, should we reduce or not. But as a human, I'm just asking you, should you reduce this to capital A? No, right? You will say that, okay, these are the three things which are matching. Now let me reduce this A, B, and small a to capital S, isn't it? Is this okay to everyone? A, B, and small a to capital S. So I think this is the very first step that we did. This is the second step we did. This is the third step we did, isn't it? This is the third step. So let's just see that. I mean, see, the steps numbers are clear to everyone. That this is the very first, then second, and third. Let's just see that what it is actually related. I mean, how the bottom of parsing, and so basically, let's just first see that how bottom of parsing and RMD are related. Okay, rightmost derivation are related. Let's just see. See what we are doing. We are in bottom up parsing. We are doing this, right? Let's say that we don't even know anything about the RMD. But at least in bottom up parsing, do you agree that you will first read A, you will go to capital A, you will then read B, you will go to capital B, and then you will read A, then you will say, oh, this complete thing is going to capital S, let me go it, right? So let's not even worry about the RMD, but at least you agree that in bottom up parsing, we will do something like this. We will go left to right, and we will start from the input string, and then we finally reach to capital S. Okay. Now, can you tell me the RMD? So see, this is the one thing that we do. Okay. This is just one thing that we do. Now I'm just asking you what you do in RMD. Okay. And then we will see, is there any even relation between the bottom of parsing and RMD? Okay. So can you tell me what you do in RMD? Isn't it? This is what you do in RMD. Is this okay to everyone? So till now, these are the two different things for you. Okay. This is RMD. This is bottom of parsing. Is the different things are okay to everyone? We will relate them. Okay. Now we will relate them. Okay. And this is RMD. These are the two different things for now. Now, see, I said this is the very first step you did, right? This is the second step you did. This is the third step you do. Now tell me, isn't it the bottom of parsing, isn't it the RMD itself, but in the reverse, in the sense that you did this a first step. So see, this was the last step, right? I mean, this small a to capital A, this is small a capital A. So basically you start from this, isn't it, from this ABA as a bottom of parser, from this ABA, now you have capital A BA, right? As a bottom of parser, now you have capital A BA. The bottom of parser has this. So basically, whatever bottom of parser is doing, it's same as RMD, but in reverse. Not exactly, because we are not starting from the start symbol. So if you look at this, now let me do just a small thing. Okay, just a small thing. Let me do. Let me just copy this, and now just very small thing. Let me do, which is this. See, tell me, isn't it the bottom of parsing? Isn't it the bottom of parsing? You are having ABA, and then the next thing that the bottom of parser has is capital A small ba, isn't it? The capital A small ba. Then the next thing the bottom of parser has, the second step, capital A is capital B, capital B, small a, and then it is having S. So this was the RMD. This was the RMD. Let me name this reverse RMD. Let me name this reverse RMD just for the I mean, actually it is a technical term only, but for the explanation I'm telling you, let's say this is a reverse RMD. Isn't reverse RMD and the bottom of parsing same? So see, you had this particular grammar. Okay, you have this particular grammar. What bottom of parsing is doing for this? Bottom of parser is saying, okay, let me reduce this to capital A, and then I mean this is the first thing that bottom of parser does, and then bottom of parser is saying that now let me reduce this to capital B. Okay, this was the first thing that we did. This is the second thing that I'm doing, and now as a third thing, what I'm doing, I'm reducing this all to capital S, isn't it? This is the third step. This is what bottom up parser says. Your RMD says this. Your RMD says this. See? Your RMD says this. Your reverse RMD says this. Okay? Your reverse RMD says this. See, many GATE aspirants just remember that, okay, bottom up parser is nothing but reverse RMD. But they do not really understand that how it is reverse RMD. See, this is reverse RMD. This was RMD. Isn't it the bottom of parsing? Isn't it same as bottom of parsing? Tell me. Okay. Just don't worry about this annotation, don't worry about this tree and all, but ultimately the essence is same, right? You are having ABA, then you are having capital A. There's a first step. There's a first step that you're doing in the bottom of parsing. Then the next step you are doing this, and the third step you're doing this. Exactly same. Let me just give you more example. Okay. Let's see this. Okay. I think this is the same grammar that we have, but yeah, this is I had the string. This is, let's suppose, D, capital A, BC, right? Okay. So this is basically, I want this to be capital A, I want this to be B, and ultimately this is S. Okay. Anyway, so let's just see that how the bottom of parser will work for this particular string. Okay. Let's just see the bottom of parsing, then we will see the reverse RMD. So what bottom of parser will do? This A, it will not do anything. For this B, it will not do okay, for this B, it will reduce to capital A, right? It will reduce to capital A. This is the first thing. Then what it is doing for the C, okay, this is capital A. I think this should be BC, right? Okay. So let's see this example. Suppose this is BC, BBC. Okay. So this will reduce to capital A. For this B, will it be doing anything? Tell me. No, right? For the C, will it be doing anything? No. So ultimately, then when it reaches to only C, it will not do anything, but it will say that, okay, currently I have this small a, capital A, small b, small c. So it will say that, okay, let me reduce this. Let me reduce this to capital A. This is the first step. This is the second step, isn't it? Now this D to capital B, this is the third step. And then ultimately small a, capital B, and E to S. This is the fourth step. Okay. So this is the fourth step. Right. This is the fourth step. Is this okay to everyone? Now let's see what is the RMD. Okay. How RMD is working. I think we had the RMD for this string. Let me just copy that. Okay. So this is what RMD is, right? This is what RMD is. Now tell me, isn't it the bottom of person doing the same as reverse or reverse of RMD? Rn2 first reducing this B, the very first step, Rn2 going from here to here. Tell me, isn't it the first step in the bottom of parsing? And then you are saying that, okay, now you reduce this ABC. This is the second step. You reduce this ABC, right? to capital A, isn't it? You are reducing capital A, B, C to capital A, isn't it the second step? Now you are saying that, okay, this D is, now you are saying D is capital B, isn't it the third step? You're going from here to here, isn't it the fourth step? So this reverse, isn't the bottom of parsing and reverse RMD same? Tell me. They are same, right? So basically whatever bottom up parsing is doing, it is same as the rightmost derivation only, but in reverse. Okay, we will start from here. If someone tell you the handle, you will go here. Someone tell you the handle, you will go here. Someone tell you the handle, you will go here. Someone tell you the handle, you will go here. It's like that only. So it's the rightmost derivation only, but since you are not starting from the start symbol, you're starting from the input string. That's why we are calling it reverse rightmost derivation. Okay, so you should all be convinced that bottom up parsing is same as reverse rightmost derivation. Okay, see here that if you are having the bottom up parsing, which is same as the in the rightmost derivation, you are doing the reverse. Okay, it seems like the rightmost derivation is going in the reverse. Okay, so now let's just do some questions and let's see that how we can parse it. Okay, as a human only. Okay, I don't do any algorithm, but as a human, can you parse this? Let's just see. Now this time we will do it little formally, which means we will use the stack and all. We will do it little formally and we will see that, okay, how to parse this as a human. Okay, so see, tell me, if you have as a bottom up parser, okay, if you have this in a bottom up parser, if you have this particular string, what you will do? You will start from this D, you will start from this ID, and then you will say that, okay, let me do one thing. Let me reduce this ID to E, isn't it? Should you be reducing by reading this ID or not? Or you will say that, okay, let me not reduce it, let me go to the plus. You will be reducing, right? Now you will be having this. So you will be reducing. Then what you do with the plus? You will go to the next symbol, and then you will say, okay, let me go to the next symbol. Then probably you will reduce this also, right? What you do now with E plus E? Maybe you can reduce this, right? Maybe it depends on you. I mean, if you want, you can go further and then you can reduce this to E, or you may reduce here also. Okay, it depends on you, whatever you are doing. But let's suppose we are reducing it. Okay, then what is the next step that you might be doing as a bottom up parser? Then you will say that, okay, let me this is E, this is E, this is E. Now let me reduce this also to E. Then ultimately let me reduce to E, right? Okay, that's how probably you might be doing. Yeah, there is another option. From here you could have taken the different track also, but let's not worry about it. I just want to convey the idea here. So you will do one thing, you will read it, right? And then you will check whether it is a handle or not. If it is a handle, you will reduce it. If it is a not handle, should you reduce it? What is a handle? Handle is basically something. If that is a handle, then you must reduce it. Okay, must. Okay, there is no escape. Okay, must reduce at handle. Okay, it's not like that. Okay, we will just shift it. Okay, which means we will go to the next symbol. No, if this is a handle, you must reduce it. So by consuming this, you will check, okay, is this a handle? Okay, if this handle, reduce it. Now you will consume E plus. Is this E plus a handle? Or maybe just plus is a handle? No, right? So since it is not, you will go further and then you will read this ID. Is this ID a handle? Yeah, I can reduce it. Then is this E plus is a handle? Then and then so on, right? You might be doing something like this. But let's just do it using the data structure. Can I use a data structure here? Okay, which is stack. Can I use a stack? Let me just tell you the need of the stack. I need a stack here. Why I need? Let me just tell you. So what I can do. Okay, see, this is going to be a little interesting, because now we are going to see the practical implementation, that how you are going to implement it. What I can do, I will say, see, you need to write the code, right? So if you need to write the code, I mean, obviously for the gate, you don't need to write the code, but ultimately to implement, you need to write the code. So if you need to write the code, what you will say, that let me just read it. Then maybe there is a pointer that you need. Can I call it an IP, input pointer? Now, if you're reading it, then whatever you're reading it, I'm just pushing that in the stack. Okay, let me maintain a stack. Can I push that whatever I just read in the stack? So can I just push this ID in the stack? I mean, just for the implementation purpose, why I need the stack, why I can't work with the any other data structure, you will get to understand. So let's just say that I'm maintaining a stack. Okay. So I have this ID. If I read it, then I will push in the stack. Okay. And what is the remaining input? This is the remaining input. Now this ID I have read it, that is in the stack. So whatever is in the stack is basically, I'm not maintaining it differently. Okay, just for the simplification, I'm not writing it differently. I'm just putting a vertical bar. So left of the vertical bar is my stack. Okay, is my stack basically. This is the stack. Is this fine? कि यहाँ तक stack में जा चुका है. Okay, so this is in the stack. This is read and in stack. This is yet to read. Yet to read. Is this fine to everyone? That this is the convention I'm following. That okay, given this, I will say that okay, if I'm reading it, okay, I mean, I will put a bar here. Now what I will do? See, now what I will do here? Let me just parse it. Okay, using the stack. Now I'm parsing using the stack. Okay, to show you that how it will be working. Let me just show you. See, you have given this. Now what you will do? You will say that okay, let me consume this. Let me consume this. And now, what is in the stack? Can anyone tell me what is in the stack? What is in the stack? Only ID, right? Only ID. Yes. So now you reduce this ID to capital E probably. Okay. Now you don't want to reduce further. You put this. I mean, you read this plus. You put this plus also in the stack. And the remaining is yet to read, right? So now you will do what? You will basically say that this E plus ID, basically this ID will be pushed in the stack. Now you will reduce this ID to E, right? Probably you will say that, okay, let me reduce this to E. Now let's suppose you're reducing this further. Okay. So basically the exactly same thing, just that I'm just putting a vertical bar. Okay. Just to tell you that things are in the stack. Now this E, and I think I should be putting this also in the stack. Should I be reducing this in the to something? This E into? No, right? Now I will push ID also in the stack. There is nothing left now, right? Now what is the next thing? Now this E into E, there is nothing left. This is E, there is nothing left, right? If you want, you can say that okay, there's a dollar at the end. Dollar, okay. Is this okay to everyone? That what we are doing, we are basically maintaining a stack. We are keep on reading, keep on pushing on the stack. Okay. Basically, we will just move this vertical bar. This vertical bar is telling you what is in the stack, what is not in the stack. So basically, we will say that this is W1, W2, W3. Let's suppose W4, W5, W6. Can you tell me what is in the stack? This is in the stack, right? This is in the stack. And obviously in the stack and obviously right? Is this in the stack? No. This is yet to even read, Okay. That is how we will implement. Just an implementation detail I want to discuss. Okay. Little bit. So maybe if this is here and there, don't worry, you will get to understand it completely. So this is in the stack, this is yet to read. Okay. And that's how we will parse this particular string. And finally, we will reach to the start symbol starting from this. Okay. Okay. See, as an algorithm, I need to maintain some data structure, right? So that's why I'm just showing you. Now tell me, can you parse this AAB? Can you parse this AAB? Let's just see. Let's just parse this AAB. So currently, this is in the stack A, B. I think this should get reduced to, okay. Now tell me, it should get reduced to B or C. What do you think? It should get reduced to B. I mean, don't worry that how the parser will make this decision. We will see. But let's suppose somehow magically you know that it should get reduced to B. I mean, as a human, at least you know, right? How the parser will get to know, we will see this. Okay, don't worry. But let's suppose somehow the parser is getting to know. I'm just telling you the data structure it will use. Okay. For now, I'm just discussing the general idea. I'm not discussing that how the parser will get to know that this is A or B or something. Okay. This will get reduced to C or this will get reduced to A. This will get reduced to B. How the parser will get to know. We are not interested currently in that. which means how the parser will find that it is a handle or not, we are not interested in that. But suppose somehow parser is finding that okay, this is a handle, then then how the parser is working, okay, then it will reduce to this. What is the next set of steps that parser will be having? It will push this a also, right, to shift the vertical bar. What is the next step? Shift the vertical bar one more time, right? Which means you are having this also in the stack. Okay, if you want, you can have some special symbol at the end. Now, what is the next step? You will say that, okay, this is the next step, right? You will reduce it. Okay, so very simple. Understood? Let me know. Okay, so basically, I just wanted to tell you that how this vertical bar is working. You may say that okay, why it is so important, but it is actually important to know that how the stack is getting maintained, because that will make the further lectures very clear. Okay. Yes. Okay. So now let's just see that how it will parse this A B C D E F G. Okay. Can you tell me how you are going to parse this A B C D E F G? Can you draw the set of states that parser will be going through for this string? So parser will say that okay, for this A, should it reduce? See, the only string it has is A B C D E F G only. Okay, this is A. Everything is just having one production. Okay, everything is just having one production. This is A, then B E, then I think this B is starting with B, this C is starting with C, D E F G. Okay, everything is just one production only. Okay, this A, I don't think parser will reduce to something. Then let's just go to this B. Tell me, can the parser reduce A B to something? No, then the parser will be doing this. Tell me, can the parser reduce this A, B, C or C or whatever? C to capital C, right? That's great. So the parser will be saying that let me reduce to capital C. Right? Now what will happen next? This is capital C. Can you tell me what should be happening next? Should it be reducing this a small a, B, C? So I think you should shift it, right? So that's called shifting or pushing, whatever you want to call. Okay, you can call it push or you can actually call it shift. Okay. I mean, here generally people use shift as a term. Okay, you shift it to the stack. Okay, so you can shift it. So shift, or maybe you can say shift the vertical bar. So this is capital C and then D, E, F, G, right? Now, can you tell me what you will do? I think you will reduce that to capital D, A, B, capital C, capital D, E, F, G. Can you tell me the next thing? I think this B, C, D should be reduced to capital B, right? E, F, G, and then you should shift this E. Yeah. So now you should shift this E. So let me just rewrite it here. This is A, B. You should shift this. Sorry, E, and then F, G. Now this A, B, E. So I think this. Okay, E is not going anywhere. You should shift this F also. Now, can you tell me this F to capital F? Now, this is yeah. We should shift this G also. Then A, B, E, F, capital G, right? Okay. If you want, you can write dollar. Okay. Everywhere you can write dollar. And then I think this E, F, G will go to capital E. A, B, E will go to capital A. And then capital S. Okay. Great. So basically, now you know how to use a stack at least, right? Little bit you might have understood. One thing, have you noticed? See, if let's suppose you are shifting, either you are doing two options. Okay, either you are shifting the next symbol or you're reducing, right? You're reducing. One thing you might have noticed little bit here, that you're shifting A, you're shifting B, then you're checking whether you should reduce or not. Okay, whether you should reduce this B or you should reduce or you should shift. So let's suppose you are shifting. Now you're reducing what? You're reducing the C here, right? Okay, to capital C. Now, can you tell me what you're doing? You're shifting here. This action is what? This is shift or reduce from here to here. This is reduce. So you're reducing this. Now from here to here, again, you're reducing this, right? Then from here to here, I think you're shifting, then you're shifting, then you're reducing this, then you're shifting, then you're reducing this, then you're sorry, then you're reducing this, then you're reducing this EFG, then you're reducing this, then you're reducing this, right? So that's how the reduce is happening. There is a very interesting phenomena which you might notice. The reduce is always on the top of the stack, which means if you want to reduce, let's suppose to you from this small 2 to capital C, will you be making this decision now or first you shift it? See what I'm saying here. Just understand this clearly. This reduce here is always on the top of the stack, which means let's suppose you want to reduce this small c to capital C. So will you be first doing something like this? Will you say that, okay, let me shift this capital this small d, and now suddenly someone tell you, oh, now you should reduce this small c to capital C. Can this ever happen in stack in this shift reduce parser or the bottom up parser? No, right? See what I'm trying to say. If you want to take a decision for the C, do it now. Okay, don't later. You can't postpone the decision. You can't just say फिर तो कैसे एल्गोरिथम काम करेगा, राइट? फिर तो ऐसे तो देखते ही रहेंगे यार, कुछ भूल तो नहीं गए, ऐसा थोड़ी होता है. ओके, एल्गोरिथम वोंट से दैट ओके यार कुछ भूल तो नहीं गए यहाँ पे, ऐसे थोड़ी है कि यार इसको मैं कैपिटल सी में रिड्यूस करना भूल तो नहीं गया. If that has to be reduced, that you should take that action now. If you are shifting it, you can't just reduce this later on. You can't reduce the C later on. Okay, so you can't say from here to here, impossible, which means that whatever you want to reduce, that cannot be between the stack. It has to be on the top of the stack, which means whatever is on the top of the stack, you take the action now. Should you reduce it? Yes. Should you reduce this C to something? No. Should you reduce maybe this BC? Whatever is on top of the stack. Should you reduce this ABC? No. So basically you're shifting. That's cool. Now, can you shift this E and then can you decide about this D later on? No, right? So you need to take the decision now. Okay, you're doing it. Now, see, the top of the stack is D also. The top of the stack is CD also. The top of the stack is BCD also. The top of the stack is ABCD also. You can reduce anything. Okay, you can reduce. So you can reduce the D also if that's what you want. You can reduce the complete CD also. You can reduce BCD also. You can reduce ABCD also. But tell me, at this moment, can you reduce this B? Only B. Can you reduce this B? At this moment? No. At this moment, can you reduce only C? No. Can you reduce this BCD at this moment? The complete BCD? Yes. At this moment, can you reduce this CD? Can you reduce the CD? Yes. So whatever is in the top of the stack, you can definitely reduce. Tell me, can you reduce the whole thing to something? If that is a possibility. Okay. So depending on the possibility, you can reduce this also. Whatever is in the top of the stack, you can reduce that only. You can't take the decision later on. Okay. That's a very important point. We will understand that very clearly. That's what called handle. Okay. That's what called handle. These are the handles. Okay. Whatever we are reducing is actually the handle. Handles are always on the top of the stack. The handle, you can't find the handle here. Okay, this is not the handle. This can never be the handle now. Only we can never be the handle now. Handles are always on the top of the stack because shift reduce parts are always reduced on the top of the stack only. It can't just go in the between the, oh yaar kuch bhul gaye the shayad, right? Okay, it just can't go like this. Okay, so Sujit is asking, sir, what if there is a production S gives ABCD? Okay, so there is one more production ABCD. And then the parser will be reducing it. It will not the parse be taking the wrong step. No. See, the thing here is that I'm currently not discussing that how to take the decision. Okay, whether you should reduce or you should shift. I'm not discussing that part. How to take the decision? Let's suppose somehow magically someone is telling me this is the handle. I'm just telling you how the stack is working. Okay, how intelligently you should take the decision. We will see that. We will see that later on, that given that you should be reducing this to capital C, or maybe you should be shifting the capital small d. Okay, always you have two options. Maybe you should reduce this, maybe you should shift this capital this small d. Okay, so always you might be having two options. I'm not discussing that. I'm not discussing how to take the action. Okay, how to make the decision. I'm not discussing that. We will see that. Okay, that how intelligently we can make the decisions. I'm just telling you how stack is working. This is stack. Suppose somehow I know that I should be reducing it. Okay, as a human, I'm just working as a human. Okay, as a human, what should happen? And then I'm just looking at the data structure, that how the data structure is basically behaving here. Okay, suppose that I know that I should be reducing it to capital C. Somehow magically I know. Okay, how the parser will get to know, we will come to that. Okay, but is this fine that how the stack is manipulated? Okay, let me know everyone, is this fine how the stack is changing? Okay, let's just do this also. Let's just do this. Pass this string. Can you pass this string? This is AB power n, okay, which means multiple ABs basically. Okay, so let's take 3 or 4 ABs. Okay, C, AB, AB, AB. Okay, so it will read C. Should you be reducing the C to capital S? Tell me quickly. Yes, right. Now this is AB, AB, AB. Now it will read A. Should you be okay? Should you be reducing this to SA to something? Okay, there is no option actually, right? So this is B, AB, AB. Now you will shift again. You will say that okay, S, AB, AB, AB. Tell me, can you reduce? Should you reduce to this to S? Okay, just quickly reduce it. Now let me directly shift. Okay, let me directly shift 2 pointers, although I should be doing step by step, but I hope you understood, right? Ek vertical bar, I missed it. Okay, so this to S. Now let me directly do this. I mean, you can put the dollar at the end. Okay, okay, so this is S dollar, right? Is this understood, that how we are parsing this? Now what we are doing here, let's just see it again. What we are doing, that we are saying that okay, as a bottom up parser, if this is given to me, then we are saying okay, this C to capital S, this is the first thing. Then we are saying that okay, this SAB to again, this SAB to capital S, this is the second step. This SAB to the capital S, this is the third step we are doing, isn't it? This is the third step. Then I mean, I have read till this point. Then I will say okay, as a bottom up parser, in the stack what I have, SAB, right? In the stack I have SAB. Then I'm reducing this to capital S. Now suppose I just reduce to capital S. Can anyone tell me in the stack what I have? If I just reduce I'm telling you the last action that I performed is reducing to capital S. Can you tell me what is in the stack? Only capital S, right? Only capital S. Okay. Now as a bottom up parser, what I'm doing here is basically I'm saying that okay, now this A, I'm shifting. Okay, so if I'm shifting, now I have this in the stack. This is B, A, B, A, B. Now basically this SA I can't do anything, so maybe I can shift to this B also. Now I have SAB, right? I have SAB. Should I reduce it? Yes, right? So now what is the next step I'm doing? I'm reducing this to S, then I'm reducing this to S, then I'm reducing this to S, right? This is what the bottom up parser is doing basically. Okay, great. Now let's just do this. Almost same thing. AB is just that I have you can say right recursion or something. Okay, I mean here this is the same, almost same grammar. This was SAB. Here I have ABS. Okay, just a little change. I just did it. Okay, I will tell you why I did it. Okay, so can you pass this? So with A, it won't be doing anything, right? With A, it won't be doing anything. Now with B, I don't think you can do anything. Oh, now let's suppose this is in the stack. What you should do? Shift or reduce? Tell me. If that is the current stack configuration, what you should do? Shift or reduce? You should shift, right? Obviously you can't reduce to anything, so you should shift. Tell me, should you shift or reduce? Okay, no chance to reduce. Now shift, again shift, right? Are you getting? We will keep on shifting, right? We will keep on shifting the vertical bar, because there is no chance to reduce. And now tell me, shift or reduce? Yes, Dibyanshu, you are right. Dibyanshu, Manshi, everyone is right. Gaurav, so Satyam, everyone is right. So we need to shift it again, right? So let's suppose it is ending with dollar. Now till now we need to shift it. Okay, so Actually, I mean, the things are same. The things are same here. So here, if you have noticed, we were getting a chance to reduce, right? This C to S, then S to, oh, this again this SAB to again S, then this SAB to again S, right? We were getting a chance to reduce early. I mean, they were earlier we were getting a chance to reduce, but here very late we got the chance, but that's fine. I mean, that's okay. I don't it's not a concern, but I'm just telling you that very late we got a chance to reduce. Now can you tell me, now we should do what? We should reduce this C2. Yes, this C2 capital S, right? This C2 capital S. Now, can you tell me what we should do now? Now we should reduce to this ABS to capital S, right? Now we should do this AB. Now, can anyone tell me now? Now again ABS to capital S, right? Now, okay, okay. That's how we are basically parsing. Is this stack okay to everyone? This is a general behavior of every bottom-up parser. Okay, that's what we do. Okay, so now let's just solve this question, and this is extremely interesting question. Let me know how many of you can answer this. So here I have ABS AB. Okay, earlier I think I was having C, but that's fine. Okay, I have AB. So what they're saying, consider the following two grammars having same languages. Okay, both of this is grammar and this grammar both are having same languages. Okay, then while parsing the string AB power n, which grammar takes theta of n stack space? Which grammar will take theta of n stack space? Extremely nice question. Just try to answer this question. If you answer this, I will be very happy. Okay. So see, this question is, by the way, from Stanford. Okay. This question is from Stanford. Let's just see if you can answer this. So you want to parse this AB power n, right? AB power n. Now they're saying that which grammar will be taking theta of n space in the stack. So what is happening here? That here, if you want to parse, let's suppose AB, 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 okay, n times. If this is the grammar, then you will be shifting it. Okay. Should it be reducing this to S? Tell me, should it be reducing this to S? Should you be reducing this to S now? In this grammar one, I'm asking for the grammar one. If you reduce to S, okay, see how to make this decision whether to reduce or not. As a human, at least you know, right? As a human, I'm talking. As an algorithm, how we will tell to the parser, we will see later on. But as a human, at least you know, right? Okay, let's not worry about that, how parser knows that we should be reducing or not. But at least you know that here, as a human, that okay, you should be not reducing. If you reduce it, then I don't think there is any chance to go to start symbol. So that's why you will keep on shifting, keep on shifting, keep on shifting, and then you will go till this point. Right? You will go till this point in this grammar, isn't it? Okay. Now you will say that okay, this should be S. So basically, you have taken order of n space already, right? Order of n space. Then you will say that okay, this is again S, right? And then you will be keep on reducing. Then you will ultimately say, isn't it? So here you have taken theta of n stack space. Okay. But if you have let's suppose the grammar 2, if you have this grammar and you have the same string, okay, now you tell me what you will do. Should you be reducing after this AB? Yes, right? We will be reducing. So in the stack, you have just one symbol here. Do you have many symbols in the stack? No. Now you have SAB in the stack. Now you have SAB in the stack. Now in the stack, do you have multiple symbols? You will reduce it, right? Are you even getting chance to have n symbols or multiple symbols in the stack? No, right? You're not even getting a chance, right? You will be reducing. So it will not take theta of n space in the stack. So grammar 2 will not take theta of n space, right? So here. So let me. Okay, the question is, This one, let me just copy this question. So here, what is the answer? That which will take the theta of n space? Grammar one, right? Yeah, Gaurav has given the correct answer earlier only. So I think multiple people have given the correct answer. Is this answer your question also, Sujit? Does this answer your question? You have asked something that the bottom-up parser will do better on the better in the sense in the stack complexity. It is at least better for the left recursive grammar, right? If this is a left recursive grammar, then in the stack complexity, it is at least better. So see here, right recursion requires more stack space. Left recursion limits the required stack space. Okay, I have taken this slide from IIT Madras. Okay, so let's do one more question. Tell me which will take less space and which will take more space. Just let me know. In theta of n space, for if you want to parse a power n, okay, parse this. Which will take less and which will take more? Just let me know. Yeah. So I think now you understood that which one will take the lesser space and which one will take the more space. So I think the first one will take the lesser space. Why? Because if you have all age, then this A you should be immediately reducing to the capital A, right? Then for the remaining this, then you will say, okay, this again you will be reducing to the capital A. So basically you will keep on reducing. So in the stack, you will not get a chance to have order of n or theta of n space basically time, right? So here the theta of n space you won't be having in the stack. You won't be pushing n symbols, okay? And here you have to take the decision at very late. So that's why you will say that this will be taking, you can say theta of one space. This will be taking theta of n space. Okay. Now let me ask you the next question, which is even more interesting. Okay. Can anyone tell me how much time it will be taking? How much time? What about the time complexity? Okay. For the bottom-up parser, how much bottom-up parser will be taking for this particular grammar? And how much for this particular grammar? What do you think? The time complexity will be same, right? Because it will be reading all the symbols. It will see for both of this, the bottom up parser will be reading this. Maybe the decision will be later on. Okay, for let's suppose this, the decision is at the end. Now this is capital A, then this is capital A, then this is capital A, like this, right? Maybe you can say the 2n time. Okay, maybe the n time in the reading, and then n more time maybe in the reducing or something, right? Then again rereading or something. But almost it is linear. Basically linear in both cases, right? Linear in both cases. So time will be same. It is just the space. Okay. In case of space, the stack will be taking more space, less space here and the more space here. Why the time is same? Because we will read any input only once, right? We will read only any input only once, and then we will be taking the decision. Maybe it is 2n, 3n, but it will be linear. Okay. Okay, so yeah, in like it might be little bit here and there in terms of like it for this it may be, let's suppose 2n, for this let's suppose it is 3n or vice versa or something, but ultimately it is linear. Okay, ultimately it is linear for both of the cases. Okay, in terms of time complexity, it is not a significant difference, but in terms of space complexity, there is a difference, right? Okay, now let's just parse this. Let's just parse this string. Can you parse? Can you parse quickly? So you will have this. Now tell me, you should be reducing this small a to capital A or capital B? To the capital A, right? Capital A. And then you will be having this. Then you should be reducing. This small a to capital A or capital B? Now to capital B, right? Now to capital B. Okay. And then to S or C, whatever, right? Okay. Now I hope that you understood that how to parse. Basically, how to know whether this small a should be going to capital A or capital B? It is a different question. That how to know what is a handle. Okay, let's suppose somehow I know that the handle here is this. Okay, how I know? That's a different question. I mean, different question in the sense that we should be making the parser in such a way that parser should get to know that this is a capital A or a small b, or capital A or capital B. But suppose somehow we know that the parser knows that okay, this is capital A, then we can parse it, at least like how the stack is working, right? Okay. So now here, tell me, if the parser is not good enough, if it is a weak parser, isn't there a chance for the parser to get confused whether it should be capital A or capital B? Tell me. If the parser is weak, not very good enough, tell me. Obviously, it will get confused, right? So tell me, can the parser recognize the handle here? What is the handle? Can anyone tell me? This is the handle, right? At position 1. This is the handle. Now the only question I'm saying that can the parser recognize the handle? If the parser recognizes the handle, it is a good parser. If the parser is getting confused, okay, whether this is a handle or this is a handle, or maybe nothing is a handle, let's just shift it. Okay, parser is saying let's just shift it. Maybe nothing is a handle. Then it is not a good parser, isn't it? So how to know some parser is good or not? Tell me. If the parser is recognizing the handle, then if the parser is confident that okay, you should reduce it to capital A, then it is a good parser. If the parser is getting confused that okay, maybe capital A, maybe capital B, then it is not a good parser, right? Now we know that okay, for any parser, it is a good or bad. So we will see that okay, if the parser is how the parser is working basically. If this is reducing to the capital A confidently, or is saying oh no, I got confused that maybe it is capital A, capital B, then it is not a good parser, isn't it? So the capability or the strength of the parser will reside in what? Is it able to identify the handle? If it is a handle, should it be reduced or should it not be reduced? Tell me. If it is a handle, can I shift? Handle means must reduce. Okay, must. You can't escape it. Handle guarantee you to reach to the start symbol, right? What is a handle? Handle basically handle guarantee you, okay, give you the guarantee that if you use me, I will make sure that you reach to the start symbol. Okay, guarantee to reach to start symbol. So if something is a handle, you should always reduce it. Okay, handle means always reduce it. Okay, if the parser is saying that this is a handle, then it is a good parser. If parser doesn't know if it is a handle, then what the parser might say? Let's suppose parser doesn't know what is a handle, then what parser might say? What are the options parser might say? Can anyone tell me? Parser doesn't know that this is a handle. Parser might say, let's just shift it. Okay. If see, parser doesn't know that this is a handle, then can't the parser say that let's just shift it? Or maybe parser say that see, I don't know actually this is a handle or not. Actually, I got confused. You can shift it, or you may say that okay, maybe you can reduce this, or maybe you can reduce this. So parser is giving you multiple options. Is it a good to have multiple options? No, obviously you want to be very precise whether reduce or not. Tell me directly, right? Why you are getting me confused? That okay, parser is giving you here 3 options. Parser is saying you either reduce this or shift it. Is it a good parser? If parser is giving you 3 options at this point in time, no, never, right? If parser is only telling me one option, it is a good parser. Otherwise, it is not a good parser. Okay. Okay. So let's see this question. Discuss the working of stack and shift reduce parser. So how the stack is working? See, let's suppose I have something, okay, uh, some string, maybe A, some string, okay. Now, how stack works? Basically, you will keep on shifting in the stack. So you will say that okay, whatever you have read, that is in the stack. Whatever you have read, that is in the stack. If top of stack is handle, you will reduce it. Otherwise, you will shift it. Right? Let's suppose you have read till this point. If this small is a handle, will you reduce it or not? Always reduce. Handle means always reduce. Okay. Handle means always reduce. So if this is a handle, you should always reduce. So you will reduce it. So how the stack is working? That whatever is read is in the stack, right? And if top of the stack is handle, then reduce it, right? Very simple. then reduce before consuming next symbol. Okay. Now tell me if this is A, B, A, B, A, D. Okay. Tell me, let's suppose this AB is a handle, or maybe this B is a handle. Okay. Now tell me, should I at this point in time, should I shift it, or should I again check whether this B or maybe this AB is a handle? Should I again check, or should I shift it? Just one handle, should I shift it? Again check, keep on checking. See, before shift, I should always make sure if the top of a stack is handle, I will always reduce it. Okay, I will always reduce it. So maybe, I don't know, maybe this is also the handle, then reduce it, right? This is also the handle, then reduce it. Maybe this is also the handle, then reduce it. Okay. Is this may happen that even this is the handle and I reduce it and ultimately I don't reach to the star symbol? Can this happen? I'm reducing at the handle only. Okay, my question is that if we reduce at the handle only, then is there any chance we don't reach to star symbol? Tell me. The answer is no, right? No. Handle guarantee you. Okay. Handle give you the guarantee. Okay. Now let's just see the next question. Yeah, that's a very good question. Can anyone solve this? Consider the following right sentences form. Left of the vertical bar is in the stack and right of the vertical bar is yet to be read by the parser. So we have read till this point, and maybe some of them, okay, some of them is a capital. Tell me, can you have the capital symbol here? Can you have the non-terminal here in this part? No, right? Because this is yet to read. Can you have the non-terminal here in this part? Can you have the non-terminal? Yes, we can have the non-terminal here. Okay. Now what they're saying, without any information about the grammar, what can you say about the possible handle? Can the W1, W2 be the handle at this point in time? Is possibly the next handle? No. W3 is possibly the next handle. What do you think? Yes. W2, W3? Yes, it may be, because top of the stack can be the handle. Otherwise, I mean, the middle of the stack or anything else cannot be the handle. W2, no. W1, no. W1, W2, W3? Yes, right? Right. So basically, B, C, F are the answer here. Understood? So these are the possible handles that we have. Great. Okay. Now, I hope you understood this. Now let's just, okay, maybe you can parse this as an homework. Okay, I think I've told you the enough example that how stack is working, right? Okay, now let's just solve this question. That where are the handles in the stack? We can find handle anywhere in the stack. We can find handle in bottom of the stack. We will always find the handle in bottom of the stack. We will always find a handle on the top of the stack. In left recursive grammar, handle are the bottom of the stack, and right recursive grammar, handle is the top of the stack. It doesn't matter what type of grammar it is, right? Doesn't even matter. So basically, handle is always on top of the stack, which means on top of the stack only I will look. If this is the handle, I will reduce. Otherwise, I will not keep on checking कि यार कुछ भूल तो नहीं गई. ऐसा थोड़ी होता है. Okay. So in bottom of parsing, like we will always look at the top of the stack. If this is the handle, reduce it. Not handle, don't reduce it. Understood? So see, in this particular example, if something is a handle, we will reduce it. Otherwise, we will not reduce it. Right? Now, okay. Now suppose this is given to me. So if this is the handle, let's suppose W3 is handle, I will reduce, I will not. If this is not the handle, I will not reduce, right? You understood, right? Whatever is the handle, I will reduce, otherwise I will not reduce. Now tell me, here in this particular example, Let's suppose I'm using some bottom-up parser. There are many type of bottom-up parser. Okay, some specific bottom-up parser is basically saying that here I don't know. Maybe this W3 is a handle, or maybe it is not a handle. Then what are the possible options it can tell me? It will say that, okay, I don't know actually. Okay, if some parser doesn't know the handle, then or maybe let me just ask you in this way. Let's suppose there is no handle at this point in time. Okay, let's suppose top of the stack doesn't contain the handle. Suppose top of the stack doesn't contain the handle. Okay, suppose top of the stack doesn't contain the handle. Now in this case, what are the options parser can give me? Now tell me, is this true? A, B, C, D. Some specific bottom-up parser or some bad parser, some specific bottom-up parser may say reduce, let's suppose A to W3. Can this happen? All bottom-up parsers will always ask to shift. Some specific bottom-up parser may say shift. Some specific bottom-up parser may say let's suppose, which is true here. Can there be some specific bottom-up parser? Maybe some bad parser. Can it say that, okay, let's just reduce it, even though the top of the stack doesn't contain the handle? No, it can say. That's the problem with the parser, right? If it is a bad parser, it can say that reduce it. Although in reality, it's not a handle. In reality, it's not the handle. See, that's what you need to understand. See, ultimately, the problem here is that parser doesn't know whether it is a handle or not. This is the ideal case. The top of the stack doesn't contain the handle. This is who know. Who know this? Who know this? Tell me, parser know this? Parser really know this? All the parser always by default know this? Who know this? As a human, we know. Okay, as a human, we know. Parser doesn't know. Okay, let's suppose as a human, it is given to you. As a human, we know that there is no handle here. But still can the parser say that, okay, this is the handle? We are going to reduce this. Can the parser say still the W3? Let's just reduce on the W3. Even though there is no handle here. Okay, can the parser still say let's just reduce? Tell me. Yes, if it is a bad parser, it can say. Okay, can the parser, all the bottom-up parser will ask to shift? What do you think? No. Not all the bottom-up parsers are good, right? Not all too good, right? Not all are that good. See, a good parser will say shift. A bad parser will say maybe reduce, or maybe I don't know. Maybe you can shift, maybe reduce. It will say I'm confused, right? So good parser, what is a good parser? It will say there is no handle, let's just shift it. That's the good parser. But tell me, are the all bottom-up parser good parser? No, right? Some specific parser may say shift, some specific parser may say reduce. That's the thing that will keep on happening, right? So here, what are the answers? See, the good parser will say shift. A bad parser might get confused, right? A bad parser might get confused. So what are the answers? All bottom parser will ask to shift. Do you think all bottom parser are that good? May not be, right? May not be. I can write a very bad parser, which will always say that, okay, reduce. I mean, whenever you see something, some possibility, reduce it. Okay. I can always write some bad parser. So all the bottom of parser will always ask to shift. Do you think all the bottom of parser are that good? Need not to be, right? Now some specific bottom of parser may say shift. Yeah, some may be good. Some there are good people in the field, right? There are good people in the world. They will say, okay, shift it. And some specific bottom parser may say this reduced to this. What do you think? Yeah, some bad parser, right? Some bad parser may say this. Some good parser will say shift. Bad parser will say reduce, right? So this can happen, this can happen. All bottom parser will ask to shift. No, no, no. All bottom parser are not that good. Okay, if it is good, okay. So see, in this case, a good parser. In this case, what will happen? Good parser will ask to shift. What are the bad parser can do? Tell me. Will get confused actually. Okay, get confused. That called shift reduce conflict. We will come to that. Okay, it will give the multiple choice. Maybe shift. It will say, okay, maybe shift, maybe reduce. Okay. Anyway, you will understand that with the more examples and with the flow of the lecture. But here, what I'm saying, that handle is something which all the parsers are looking for, right? If it is a good parser, then it will say that shift it. If it is a bad parser, then the bad parser may get confused. Okay, understood? So maybe this handle and these things are a little bit clear. Don't worry, it will be more clear. Okay, don't worry, it will be more clear. Yeah, parser doesn't know what is the handle. So basically, the job of the parser is to find the handle. Okay. If it is a good parser, it will find the handle. If it is a bad parser, it will not be able to find the handle. Okay. So the job of the parser is to find the handle. Is to find the handle. If there is some good parser, it will say confidently that, okay, this is a handle or this is not the handle. If it is a bad parser, it will get confused. It will say, okay, I actually don't know. Maybe it is a handle, maybe it is not the handle, right? So it is a job of the parser. Now good parser will always find it. Will find it. Bad parser will not be find it, right? Bad parser will not be able to find. Okay. So this is the job of all parsers. Now let's just parse these strings here. Maybe let's just quickly parse A B A. Okay, can you parse A B A? I think for A A, right? So this is B, right? This is B. Okay. So what you should do? You should shift it. You should shift it. You should again shift it, right? You keep on shifting. You again shift it. Then this is B, I think. And then this is BA. Okay. And then this is S. Is this okay to everyone? For this string. Now let's just parse this all the age. Okay. So there are two strings that we want to parse. Now let's just parse all the age. So this is all the age, then all the age, right? So I think this is A, and then A, right? So maybe, okay. So shift it. Then at this A, you again shift it, right? And then understood? Okay. So that's how you can parse it. Now, do you notice very interesting thing here? See, this is string given to me, this is string given to me. Tell me, a parser look all the string at a once, or it will be doing step by step. First this, then this, right? Step by step, right? Now, whatever parser you build, see how intelligent parser we should be building for this particular grammar, because whatever parser you build, first of all, it should be able to tell that this A, the moment you read it, it doesn't mean you should shift, you should reduce to capital A. Tell me, should it be reduced to capital A? The moment you read it, no, right? For this string, at least no. Now you are shifting it. So, you have double A. Now you might notice very interesting thing here and here. These two are same. I mean, as a parser in the stack, at least I have seen the same thing, right? In the stack, at least I have seen the same thing. Now here I have taken the decision to shift, but here I have taken the decision to reduce, isn't it? See, in the stack is the same. Is the same in the stack. So now here the parser is taking the decision to shift. Here the parser is taking the decision to reduce, right? If the parser is that much good that for this string, okay, for this string, it is taking the decision to shift. For this string, it is taking the decision to reduce. It's really a good parser, isn't it? And we will see that how to design such a good parser. Any idea that how we can design such a good parser? That looking at this string, at least, okay, let me just give you the hint. At most, you can see next symbol. Okay, you can just see next symbol. Based on that, you can decide whether to shift this symbol or whether to reduce it. So maybe we will see that how we can design such a intelligent parser, that looking at just a next symbol, maybe it is deciding here to shift, here the next symbol is small a, then it decided to reduce. See, as per the stack agent, it's the same. Tell me first. As per the stack agent, it's the same. These two things are same, right? Now the parser should be intelligent enough to tell me that now you should reduce here, you should shift here. Sorry, you should reduce here, you should shift here. We will see that how to design such intelligent parser. Okay, for this grammar or for any other grammar. Okay, but as a human, at least you understood that how the parsing algorithm might be working, right? If someone tell you that shift or reduce, if someone tell you the whole mystery that it is a handle or not, then can't you at least see that how the stack is behaving? Okay, you can definitely see the how the stack is behaving, right? Okay. So I think let's just immediately do this last example to parse this. Can you parse this? This is the same thing that we did multiple times, I think. This is E. So in between, this is AE, right? AB. And also this is B. So this is A. This is A. This is B. This should be small a. This should be small e. Okay. So how you will be parsing it? This is A, B, B, C, D, E. Now this is small a. Should you reduce it to something? No, right? This small a should be as it is. Then this is B, B, C, D. Should you reduce now? I don't think, right? This B will not go anywhere. Or you should reduce. Yes, you should reduce basically. This should go to capital A. So this should go to capital A actually. So this is capital A, B, C, D, E. Now, should it be reducing this small a capital A to something, or there is any such kind of things? No, right? So what you should do? You should shift again. Now you should shift it. Small a capital A, small b, C, D, E. Then you should again shift it. Now you should be reducing this capital ABC, right? This capital ABC to capital A, isn't it? So you should be reducing it. Then you should shift it. Then you should be reducing, right? Can anyone tell me what should we do now? We should reduce this small d to small d to capital B. And then okay, understood. So basically, if you notice, then this is small a, this is small a, or maybe this is small a capital A. Yeah. So maybe you can notice something, that this small b, at least this small b, we have not reduced to capital A, right? We have reduced, instead of reducing this, we have reduced this capital ABC. So here, if you notice this, at this small b, what we are doing? Shift to reduce. Tell me. If we have small b at the top of the stack, we are doing what? We are shifting. At this small b, what we are doing? We are reducing, right? We are reducing. Here we are shifting. So basically, parser should be intelligent enough to tell me whether this b is a handle or not, or whether this b is a handle or not. Okay. So see here that this b is a handle or not. Tell me. This is a handle. Is this a handle? This top of a stack is not the handle, right? So here, if you notice, then we are saying that here, the first b was the handle, then this was the handle, then this was the handle, and so on. So here, this b was the handle, but the moment you reduce to capital A, but this b is not the handle, right? This is not the handle. Okay. So basically the thing is that ultimately the thing I want to say that parser should be telling me, okay, it's not the magic will be telling me, the parser should be telling me whether I should reduce or not. But at least the working, okay, the generic working of any bottom-up parser is okay to you, right? If let's suppose somehow the parser can tell me, okay, that you should shift or reduce, okay, it just need to tell me whether to shift or reduce, then can you write the algorithm, which means can you just implement it? Let's suppose I give you a function, okay, function to tell shift or reduce. Given this state, okay, given this state, the function can tell shift or reduce. Okay, it will say shift, it will say reduce. Can you do the rest of the thing? At least the generic working is clear to everyone of you, right? That how the stack is basically working. So how things are getting filled in the stack. Because actually in the bottom of parser, the stack is very important. That's why I have taken this much time to explain you that how the stack is working, right? So obviously the question is how to find the handles. Because if you can find the handle, then you can do all of this mystery. So now based on the ability of the parser to recognize the handles, we have many types of the parser. We have LR0, we have SLR1, LLR1, LR1, and there are many others. But in our syllabus, we have only 4. Okay, we will see only these 4. So let me just summarize that in the bottom of parser, it will keep on shifting in the stack, right? So the bottom of parser, it is also called shift reduce parser. Okay, but you can call it anything. So the bottom of parser will keep on shifting in the will shift input to stack one symbol at a time. And keep on checking if top of the stack is handle or not. If it is a handle, then what to do? Reduce. If not handle, then shift. Okay. What a bad parser can do? A parser is bad if it doesn't know whether the top of the stack is handle or not, right? Okay, this is a bad parser. Okay, hope that's fine. Now that's all I wanted to discuss in this lecture. Now from the next lecture, we will see LR0, SLR1, LLR1, and LR1. So till now, we have just built some foundation that what these parsers are doing. So can anyone tell me in just one line what these parsers are doing? Any of the bottom of parsers, what they are doing? All are in just one race. What is that race? Is top of the stack handle or not, right? They all are just in one race. What is that race? Is top of the stack handle or not? If it is a handle, they will reduce it. If it is not a handle, they will not reduce it. So basically here, these parsers are like that. This is actually the weak parser. Okay, it sometimes it get confused for some grammars. Okay, this is little strong. This is even more strong. This is even more strong. Okay, in that order we will see. that okay, this parser may get confused. It may say for some grammar, it may say that okay, I don't know for this grammar. For other grammar, it may say that okay, I'm confident for this grammar. I will always tell whether to shift or whether to reduce. But for some grammar, I will get confused that okay, whether to shift or reduce. So I will not be able to tell the handle for some grammars. Okay, this will say that okay, I can at least parse more grammars than whatever you did. So it is more powerful. It is more powerful. It is more powerful, like that. Okay, understood. So now we will not discuss the handle anymore. So let's just pause this discussion for the handle. Now we will see all of these parsers, and we will solve all the gate questions. We will solve all the standard university questions, and I will not bring this handle word again. Okay, for at least once this parser is finished. Later on, we might be having just 1 hour discussion more, that I will just connect all of this, that how all of this is connected to the handle, but we will not again, I will not use this word handle again. Okay, so the reason why I will not use this handle word again, because I don't want you to get confused. I want you to solve the questions in gate. So in gate, just these are the very simple algorithms. Okay, just extremely simple algorithm. Okay, now in the gate, if you know that okay, how this parser is working, you can directly tell that okay, for this given grammar, if this parser will work or not. Okay, so we will see all of these parsers, and then once the whole discussion, all the questions, every gate question, every standard university question, everything is finished, then only I will connect back that how they are connected to the handle. Is this fine to everyone? Okay. So first we will see all of these parsers, and then we will connect back to the handle later on. Okay. So thank you everyone. That is all for this lecture. I hope you understood. If you are watching it like later on, like offline, then you can just let me know in the comments that if there is any confusion or you like that lecture or not. Okay. If you liked it, then just put a comment there. Okay. So thank you everyone. Take care. So just to summarize what we have seen in this lecture. Stack or bottom-up parser. Okay. Stack, or you can say a generic working of any bottom-up parser. That how does the bottom-up parser work? Okay, and now we will see in the next session that how all of these are actually algorithms are working, and then we will connect back to the handle and other things. Okay, cool. So thank you everyone. Take care. Bye bye. Just put a comment later on the video if you understood everything. Okay, just let me know if you have understood everything, because it really motivates us that okay, whatever we are teaching, it is actually getting delivered to you guys or not. Okay, thank you. Take care. Bye bye.